Hello, welcome to this video on Makecode Arcade. So Makecode Arcade is a fantastic way of introducing coding and games design to students. There's a whole range of really good tutorials which introduce lots of different concepts of sprites and moving and lives, etc. And students at the end of these tutorials, in theory, should be able to create their own games. In practice, I find, though, tutorials have a small issue that often we follow them and don't really understand what is going on. So this video doesn't aim to be a tutorial as such for a specific game or anything, more talking about some of the key concepts behind Makecode Arcade of how it works. The issues I find students have are one of two ways. One, they've followed a tutorial and things are just not working and they're unable to fix the issues themselves because they haven't really understood what's happening, or when they get to that next point where they want to extend a game or make it their own, again, without that basic knowledge, they're unable to do that. These are the points I intend to cover, starting with the basics such as resolutions and sprite sizes, etc., moving on to things like velocity, acceleration, jumping, tile maps and walls, eventually leading on to more complex things like how we might create maze and side-scrolling games. The screen resolution for Makecode Arcade is very different to that of a typical modern-day machine. We have a much lower resolution of just 160 pixels in the X direction, 120 pixels in the Y direction. Also note that for computer graphics, the origin starts in the top left-hand corner, and the Y is positive as we go down the screen. And all of these factors we need to take into consideration if we're creating background images, looking at the size of sprites, or trying to move sprites across or around the screen in terms of positive and negatives for different directions. For example, when you're choosing a sprite image, you might go on and choose a sprite such as this, but it's really important that you have a look at the resolution that that sprite that you're choosing is. So if we were creating something that might be a player or something within a game, most of the time we're not going to want to have sprites that are as large as this. Common size for sprites that are used in games are typically for players and enemies, etc. are typically 16 by 16. These take up a reasonable amount of space on the screen so we can see them, but not that big that they take up most of the screen. We'll learn later that actually 16 by 16 pixels is a good size if we're working with tile maps as well. And there we go. That's perhaps a better size. Let's have a little look about velocity next. I'm going to use some blocks here to help us learn about velocity. We probably have seen how we can move sprites with buttons, but if we use this, we can change values in here, such as the velocity in different directions. So velocity is a mixture of speed and direction. So in this case, I'm going to have an equal movement speed for my sprite in both the X and the Y value, which is about 100 pixels a second there. So that's going to take roughly about 2 seconds to move up or down the screen because of those speeds. If we want to go faster in either of those directions, we can obviously change them. As you can see, they're going to move a lot faster now. Sometimes, though, we want sprites to only move in one direction. So in this case, I'm going to build a little bit of a jumping type scenario here. And what I would want is to be able to, for the direction to change, in the X direction. But I don't want the player to be able to use the controls here to change in the Y direction to go up and down. So here I'm going to allow the player to be controllable in the X direction, but not be controllable by the controller here in the Y direction, because I'm going to add some code to make it kind of effectively jump. An example of where I see students not really understanding this idea of vectors being with direction and speed is in the Galga game. They complete the tutorial, but what they do is when they are setting up the projectile that's going to fire from the spaceplane, the default velocity is 50 in the X and 50 in the Y. And what this does is it results in a vector, a resulting vector, that then is literally going from top left towards the bottom kind of right. and they miss out the step that says they want to change the velocity in the y direction to be 0, that would allow the projectiles to go straight across the screen. Now what we're going to do is we're going to look at how we can have a combination of this idea of acceleration for gravity and velocity for speed to implement a jumping feature for our sprite. So we're going to say that when the button A is pressed, we want my sprite's velocity in the y direction to be -150. And I remember a negative number in the y is actually an upward direction. So now when we start the game, it starts to fall, and I can kind of start to sort of press this A button to make my sprite kind of jump. Obviously, we've got nothing to land on, and it's going to go off the screen at that point. So that takes us nicely into the next idea of something called tile maps. And a tile map is essentially something that we can put on our screen that, first of all, just provides some graphics. As you can see here, we've got some graphics where we've got a brick wall and a path and things there. Now, the way I've set my tile map up already for this demonstration is that the bottom part of the tile map is actually what we call a wall, and we'll see what that kind of means in a minute. We go to edit a tile map. Quick thing about tile maps before we start, they are essentially tiles are pictures that have sort of loaded into a game that cover a certain sort of size. A tile itself is 16 pixels by 16 pixels, which would mean based off of the 160 by 120 resolution, we get 10 tiles we can fit across the screen and 8 sort of tiles that we could fit down. There's a whole load of preloaded, pre-designed tiles sort of built into Makecode Arcade that we can kind of pick and choose, and literally pick a tile and we can draw it on the screen, and we can do lots of other sort of things with them there with the editor. What you're seeing here though, this red, well, this is a sort of special tile, and what I'm actually going to do is remove that on the eraser here, but be on this special tile called the wall one. And if I kind of paint over the areas that are red, you'll see the red color is disappearing. You can see the normal color of the tiles underneath. Let's see what happens when we do that in our game. Essentially, we just fall straight through them. So based off of that, you can hopefully see that what this wall tile is doing is saying, although we have a picture of a wall in my sprite, in my tile map, it doesn't actually do anything to the game apart from being a picture. However, when I now use this wall tool and paint those tiles to be red, now the game understands that they actually are walls and stops sprites from passing through them. So if we're creating a game now that was going to be using something like this for a platform game, we can kind of go up here and we can jump. Now I've got a bit of a problem though. My buttons allow me to keep pressing and I can kind of go up as high as I want. Whereas most sort of platform type games like this, or side scrollers and things, will be using gravity, and the idea would be that we shouldn't be able to press the button again until we have kind of landed. There's a couple of ways you can do that in Makecode Arcade. This is one of them. And what I'm doing is I'm putting an if block inside of my when the button's pressed that says only change the velocity of the sprite if the current velocity of the sprite is 0. What does that mean? Well, if we have a velocity of 0, that would mean that we are not moving. So we are stationary. So now when I press my button A, it will only kind of effect once until I've landed, and then after that again it will take this -150, pushing the sprite up into the air. If I keep pressing it whilst I'm up in the air, my velocity isn't 0, it is not taking that action. If you followed the maze tutorial, you'll end up with a very basic maze program. It's a natural thing that you would want to go and improve on that. So I'm going to show you a small game that I kind of created that's a maze-based game, and talk to you about some of the things that are in there. So first of all, I used something I would call a portal there. And now here we go. You can see I've got sort of things that are going to chase me. So I'm playing my game. I also have this idea of sort of a score. And the idea is that I can pick up some objects. So I'm going to show you how you can kind of make objects appear and then kind of disappear. Oh, okay. Let's go back to any code and have a little look at some of these things. So first thing was that we maybe saw there that you haven't seen before was this idea of having a sprite that is able to chase you. So here we go, creating another sprite. In this case, a monkey, and it's going to be of type enemy. And the chasing bit is as simple as this. We're going to add the block from the sprite section that says set my sprite to the monkey to follow my sprite the player. That's as simple as it is for that. Okay. Okay, next then is how do we have collectibles? Well, in this case here, to do collectibles, let's see if we can find the code. It's all a bit squashed. So I'm using this idea of something called a chest. Well, this sprite as a chest. I've placed some of them in my tile map. The idea is that I check to see when a player overlaps with the chest tile. Play a little sound. So this sounds nice and easy to do kind of here in Makecode. But the important bit is that what I need to do is be able to change it so that when I do that collision, that I essentially reset the sprite to be no longer the chest. I change it to be the path that it's kind of on. And I do that by using the location that we have here in order to figure out the column and the row that the chest was on. In order to access the separate row and columns, you'll find a block inside of the scene area down here where we can drag one of these in. So we're using the location there, and then we're setting either the row or the column that we need, or setting the rows and columns that we need in order to overwrite that. I've also got this idea of I'm using something called score, and every time we collect the chests, I'm adding one to my score, and I use the idea of score for unlocking things. So, for example, once we have collected the 3 chests, I have another tile that is calling an orb here, but I'm only going to do anything with that one when my score equals 3. So therefore we needed to collect the 3 chests before we can activate the orb. And the orb is then going to allow us to unlock a door that will allow us to sort of go through the door and get to the sort of final level on this game. Okay, I hope you found all that useful and you enjoy making more games with Makecode Arcade. Thank you for watching.